All right, so in this video, we're going to continue with question 5 for this one. F of x equals e to the power of negative x dot square root of x. So I'll just write it down. I'll just bring it down here so we can see the function. See, sorry, let me bring it down here. Okay, now first, is there a vertical asymptote? So at the vertical asymptote, the limit of f of x as x approaches a particular value, let's just say a, the limit of this would be infinity, or in some ways we will say undefined. Okay, so is there a number? Okay, is there a number that as x approaches this value, we're gonna get it infinity? Or is there a place that will give us, or is there a place along this function that will give us undefined? If we look at these two functions separately, an exponential function and a square root function, generally none of them have vertical asymptotes. Okay, an exponential function will have, let's say, a horizontal asymptote. Okay, but generally, like as long as x is greater than equal to 0, this is a continuous function. An exponential function does not have a vertical asymptote. A square root function also doesn't have a vertical asymptote. So generally, these two multiplied together, you actually have a continuous function. Okay, so there is no vertical asymptotes. So there's actually a question mark sign. Okay, as long as x is, and if you actually draw the graph, you have something like this. Okay, so you have something like this, something like this. There's no vertical asymptote at all for this function because each of them separately, an exponential function has no vertical asymptotes. A square root function also has no vertical asymptotes. Okay, so do with this whatever you know. So there's no vertical asymptote here. It's a continuous function. So we can say this one, f of x is f of x, which is equal to e to the power of negative x dot square root of x, is a continuous function, no vertical asymptotes. How about horizontal asymptotes? So in the horizontal asymptotes setting, the limit of f of x as x approaches positive or negative infinity. Now, since we remember the domain of this function is x is greater than or equal to 0, so we can actually ignore the negative infinity part because x is not going close to negative infinity. So the limit as x approaches infinity of f of x will be equal to a particular value. So I used a in the last one, I'll just use b. So b. So is this possible? Is there a vertical? Is there a horizontal asymptote? Let's see. Let's see. Now, what's the limit f of x? So this is the limit of e to the power of negative x dot square root of x as x approaches infinity. Okay, let's look at this function. Let's rewrite this function. We can rewrite this as the square root of x over e to the power of x. Why? Why did I write it like this? Because remember, this is a negative value. We can write it like e to the power of x will be the same as 1 over e to the power of x. E to the power of negative x will be equal to 1 over e to the power of x. So now we have this square root of x over e to the power of x. Okay, so we have the limit of root x over e to the power of x as x approaches infinity. Now, if x gets closer and closer and closer and closer to infinity, the square root of x will also get close. Just imagine. Let's use squares now. 4, 9, 16, 25, 36. The square root will be 2, 3, 4, 5, 6. So as the square, I'm just using, although you can actually, I'm just using real like a perfect squares to explain, but you can actually you can use, as it increases, it's still increasing normally. Okay, so as the value of x increases to infinity, the square root of x will also be going to infinity. So this is kind of infinity. E to the power of x as e to the power of x, so e to the power of 1, e to the power of 2, e to the power of 3, e to the power of 4. So as x gets closer and closer to infinity, e to the power of x also gets closer and closer to infinity. So we have infinity over infinity. What do we do now? We have a stumbling block. What is infinity divided by infinity? Can we do that? This is where the l'hôpital, hospital, if you don't, l'hôpital's rule. Like when you have this situation, this is indeterminate form. Okay, when you have an indeterminate form, you can now use the derivatives. Okay, you can use the derivatives. Okay, and when you have that, so let's say if you have the limit of, let's say, f of x over g of x is equal to infinity over infinity. As x approaches a certain value, it can be infinity. Since we're in infinity here, let's just use infinity. Okay, then we can actually, this can actually be equal to the limit of f prime of x over g prime of x. So we have just get the derivatives of each of them. Okay, so what we just have to do now is get the derivative of this function over a derivative of this function. Don't use we don't I need to use the quotient rule. Don't do that here. Just take them one by one. So we have root x over e to the power of x. So what's the derivative of root x? Okay, so I'll just do that for, so this is the same thing as 1 over 2. Okay, what do we do? Multiply the power by the coefficient of x here, which is 1. That's going to be half. So 1 times half is still half. So we have half now, minus 1. So we have half x to the power of negative half. So we can rewrite this as, half times 1 over x to the power of half. This is 1 over 2 times 1 over square root of x. And overall we have 1 over 2 root x. How about e to the power of x? It's still the derivative of e to the power of x is still e to the power of x. So what we have now is actually 1 over 2 root x over e to the power of x. You can write it like this: 1 over 2 root x divided by e to the power of x. We can change this to multiplication. This becomes 1 over 2 root x times 1 over e to the power of x. So when you have a division, you just change multiplication by saying, taking it as 1 over, because this is the same thing as e to the power of x over 1. So when we change to multiplication, we just turn it upside down. So overall, we have 1 over 2 root x e to the power of x. Okay, so let's bring that our limit back. So the limit of, now the function we have is 1 over 2 root x over e to the power of x, limit as x approaches infinity. Now what happens here? As x approaches infinity, root x also approaches infinity, e to the power of x also approaches infinity. So it's like infinity times infinity. So you can ignore the 2. 2 times infinity will still be infinity. So overall, we have 1 over infinity. So 1 over infinity, the limit of this will give us 0, 0, 0, 0, 0, 0. Ask how many times LB. Oh, sorry. So 1 over infinity, so this gives us 0. This gives us the limit as 0. It means that this approaches, gets closer and closer and closer and closer and closer to 0. So the question I may ask that, didn't we have 0, when we talked about, I mean, this, when we talked about the y-intercept where x is equal to 0, didn't we have that? Yes. But if you actually look at the function, so let me actually get the graph of this function. Let's see, I'm sure what it looks like. Like, why would we have a vertical horizontal asymptote at 0 when we already have, when 0 was the first value? I'm just going to share the picture. Sorry. Oh, oh, sorry. Okay, we're back. All right, so you can see now, look, so this is the actual, this is how the graph looks like. You can see, yes, we started with 0, but now as x gets closer and closer to infinity, you can see as increasing, it's going down again. It's getting closer and closer and closer and closer to 0, but it doesn't actually reach 0. Okay, here we have 0, 0, fine, okay, but then as we go like this, as we go like this, as we go like this, it's going down again. It's getting closer and closer and closer and closer and closer and closer and closer to 0, but it doesn't actually touch 0 anymore. So yeah, it's still a horizontal asymptote. Not in the way most people would see it, because we expect that it never actually touches 0 at any point, but then, it starts from 0, and then it's like it wants to go back to 0, but never actually goes back. I'm sorry. So yeah, so the vertical asymptote is 0. There's no vertical asymptote, and for the horizontal asymptote, it is 0. So I think, yeah, then I think these ones will now be separate separate videos, so that I don't mix different concepts together. So this video will just be for vertical asymptotes and horizontal asymptotes. Then the next one, I'll answer intervals of increase and decrease, and then find the local and maximum, minimum, and local maximum values. So thank you.